SAP HANA system. I will go over these components one by one so you will have a good understanding. Let's start in the left corner above. Number 1. Client application that connects using SQL or MDX. The SQL is the standard or structured query language to interact with databases, invented way back in the 70s in the IBM labs, pretty much at the same time when the database was invented. MDX, or multidimensional expressions, does pretty much the same, but then for OLAP databases. That is, a database specialized for analytical purposes, the data warehouses, where data is modeled in cubes and not in tables. Microsoft came up with MDX in the late 90s. You use it in Excel, for example, with pivot tables. So, what kind of a client application would this be? Well, any kind of client application, in other words. Any application that processes transactions, insert, update, delete using SQL, and any application that performs analysis on large buckets of data, even on big data. Here we see an example of an analytical application. SAP HANA supports both relational row storage and analytical column storage. It all runs inside the same engine. And for this reason, you can use both types of application. To connect to the HANA server, some plumbing is needed. Database drivers. HANA supports both ODBC, Open Database Connectivity, and JDBC for database connectivity using the Java programming language. There is a HANA client software package for the Windows platform, for Unix and Linux, and also for IBM I, or OS400, for the IBM Power Systems. Java runs on any operating system, so no matter what your client operating system looks like, you can install the middleware to connect to a HANA server. This brings us to number 2, a client application that connects over the internet using HTTP. This is a technology that became popular in the 90s as well. Here there is no need to install any client software on a desktop computer to connect to the database. We're using here web technology and an application server that processes HTTP requests. The good news is that HANA is not only a database, it's also a platform, and it includes a built-in application server. I said built-in and not glued upon. It is completely integrated with the other database processes. Here we see a picture of an SAP Fiori application that is accessed using web technology on a desktop and different mobile devices. Fiori is a technology that SAP uses to standardize user interfaces, so the look and feel of SAP applications. No matter what type of device you use, the application will have the same familiar UI. And 1 plus 2 here means that you connect any application to the SAP HANA database. Let's move to number 3. Well, it's the same idea, web-based development and administration tools. Client tools that run in a web browser and connect to a web server using HTTP. Here we see an example, the SAP HANA Cockpit. With this tool you can manage your HANA database, monitor performance, manage alerts, manage security, you name it. Runs on any HTML5 enabled browser, runs on any device. Very convenient. Same for the development tools. Here we see the SAP HANA web-based development workbench editor. Includes code completion, debugging, tracing, source control. Very powerful. And just as for the administration tool, there's no software to install. It's all over the web. Number 4 here is SAP HANA Studio. This is the development and administration tool as a full client, so both are combined. It communicates with the SAP HANA server using SQL most of the time. HANA Studio is a plugin for Eclipse. And Eclipse is an integrated development environment, or IDE as it's often called, originally conceived for Java development, again by IBM Labs in the early 2000s this time. It's an open environment, open source tool now, and there are literally hundreds of plugins available on the Eclipse marketplace that extend its functionality. You can turn it into a C or even C++ development tool, or use it for PHP, Python, Android development, and so on. SAP has contributed with a number of plugins as well. It is now the standard tool for ABAP development for SAP NetWeaver. There are modeling tools for SAP Business Warehouse, BW. The UI Development Toolkit for HTML5 is a plugin, as are all the cloud-based development and integration tools for the HANA Cloud Platform. And, as just mentioned, for SAP HANA. Eclipse runs inside a Java virtual machine and for that reason uses JDBC, the Java Database Connectivity Component. For example, I can click here in the Administration Console on this version link to get the current HANA version. What happens behind the scenes, or behind the screens, I should say, is that Eclipse translates your clicks into SQL and sends it to HANA. It gets a result back and displays it nicely in a window. So almost all the screens are populated using SQL. Now if you want, you can activate SQL or JDBC trace, and if you want to know exactly what goes over the wires. HANA Studio is available for the Windows, Linux and macOS platforms, same as with Eclipse. Here we see Studio on the Mac, looks pretty much the same as on Windows. Next, we're going to take a look at number 5, that is the SAP HANA system. The main processes that together form SAP HANA are shown in the box. First, there is the name server. The name server manages what is called the topology of an SAP HANA system. HANA is designed such that it's very easy to scale out. You can start with installing HANA on a single computer, a single server, to host the HANA database, and later add more servers to create what's called a distributed system. In a distributed system, we still have a single logical HANA database, but now there are multiple instances running. Each server or host has HANA processes running. This is the HANA instance, and together the HANA instances make up the HANA database, or HANA system, I should say. We can see that here. We have two hosts with an identical HANA installation. They both run an instance. The instance has the same name or system ID, SID, and here the SID is HTTP. And the instance has also a unique number, 2 digits. Here the instance number is 01. Together, this creates a single logical HANA system. The database data and log files are on shared storage, as the operating system processes on each host need to have access. A distributed system is implemented for scalability. A system with 2 hosts can serve twice as many users as a single one. But it is also critical for availability. Should anything happen with a single computer, the system will still be available. And for large production systems, there may be 10 hosts or more. So you have 10 instances, 1 database. Now, as mentioned already, HANA is more than a database. It's a whole platform that includes a web server and an application server and some other processes, which we will take a look at in a minute. To keep track on which process runs on which host, HANA uses the name server. The name server is running on each HANA host, but there is one name server that is the master. That's the boss, but together they manage the HANA topology. If you have very large tables, say a table with sales data of a few terabytes, and you have partitioned that table in regions, Americas, Europe, Asia, you could, for example, host one partition on server A and another on server B. And this locality information will be stored by the name server as well. It's a small process, doesn't use much memory or CPU, but it is critical. You can't run a HANA system without it. The next component we will mention here is the preprocessor. The preprocessor server is used by the index server to analyze text data and extract information from that data using text search. It is used by the SAP HANA text analysis technology to work with unstructured data like documents, PDFs, emails, but also Twitter feeds, anything which contains text. It's a bit of a search engine. Number 7 is the compile server. The compile server performs the compilation of SQL script stored procedures, amongst others. A well-known limitation of the SQL language is that you cannot combine it with any programming logic. You cannot do any if, then, else, any looping while true, do this. So every major database has its own procedural extension to SQL. Oracle has PL/SQL, Microsoft T-SQL, and so on. And for HANA, we have SQL script. In order to run this inside the database, you need to compile it, and that is what the compile server does. Okay, number 8, the index server. This is the database engine, the core of the HANA system. The index server contains the actual data stores and the engines for processing the data. Here we can see a schematic representation of this index server. We're not going to discuss this here in detail, but as you can see, we have connection and session management, authentication, are you allowed to connect, authorization, what data can you access, a transaction manager, a persistent layer. HANA processes all data in memory but needs to persist transactions in case of a power failure or earthquake. We don't want to lose any data. And there are the different engines for SQL, MDX, SQL script. There's the different data stores, row storage, column storage. Now, this is just to give you an idea. There's more to it, but that may be the topic of another video. Number 9, the web dispatcher sends HTTP requests to the application server for dynamic content. For static content, images for example, it will serve these directly to the client. It's just a regular web server. And finally, we have the application server, or extended application services, access server I should say, and this extended application server provides applications and application developers direct access to the database, transactional and analytical, and to a number of components included with HANA. We've already discussed native text search, and there's a planning engine built in. There is predictive analysis, spatial data for application that wants to use geographic locations, and so on. Now, the main advantages of this built-in application server can be seen here. With an external application server, you will need to transfer all the data that's needed for processing from the database to the application server. With HANA Access, both application server and database have direct access to the data store. No need to move any data. All the processing takes place in memory and on the location where the data is stored. Okay, now with this knowledge, you should be able to read more complex diagrams, like the one here, for example, from the SAP HANA Master Guide. This diagram shows client access, protocols, and ports. Below the user, we see on the left the clients that use ODBC JDBC for SQL and MDX, HANA Studio, BW, and Business Objects, Business Intelligence tools, SAP Business Suite, Excel, and on the right we see HTTP access for web clients. Also included here on the left are components like SAP Event Streaming, SAP Replication Server, SAP Data Services, and even how SAP Support and SAP Solution Manager access the HANA system. You can pause the video if you want a closer look, or even better, download a copy of the SAP HANA Master Guide and read a chapter on SAP HANA Architecture. If we take a quick look here at a live system with the SAP HANA Studio, and we can see the different processes listed here on this view. We see the name server, index server, preprocessor server, access engine, and the web server, but there are also other processes, as I mentioned. This is just the first introduction of the SAP HANA architecture. Okay, that's it. The SAP HANA architecture is documented in the SAP HANA Administration Guide and the Master Guide. You can access and download SAP HANA documentation free of charge on help.sap.com/HANA. Thank you for watching this SAP HANA Academy video.